Introduction to Async ADTs. Hello, my name's Tom Wilson, and I'm going to do a demo today on Async ADTs. This is a super confusing subject, and if you're not familiar with a little bit of functional programming, more than likely this is probably going to confuse you a lot. But I'm going to try to keep it simple and try to go through it. I do have a previous demo on just understanding ADTs in general. ADTs are algebraic data types, and I recommend you watch that video before watching this video so that you get an idea of kind of the patterning um, with ADTs. So, why do we want to learn ADTs? It's a hard concept, it's a steep learning curve. We want to create highly maintainable, extendable, reliable software. There's several ways to go about doing this. ADTs is one that can greatly simplify the process and just create very easy to follow guardrails to kind of keep you from injecting kind of side effects in your business logic. There's other ways to do that, like patterns like flux architecture, for example. But one of the challenges with that is kind of the way it spreads kind of your business logic in action creators and then reducers and selectors. It can not be as maintainable as something like ADTs. So, with that said, we're going to pop over to our kind of REPL here, and we're going to take a look at some ADTs. In a previous demo, we actually created a very simple ADT called ID. And ID takes a value and then it returns a kind of container. And this container has a map function, and that map function takes a function as an argument, and then it returns it replaces the value in the container by returning a new container and running that function on that to get the new value. And then a chain takes a function and it just returns the result of that function because that's going to be a new container, right? The chain works like a flat map. It takes a new container and replaces it, replaces the current container with the new container. Kind of see how that works. And then finally, we had like an extract method, and this extract method just allows you to access the value from the container, kind of pop it out of the container. So that's our, uh, very simple ADT, and we can work with that by um, running, you know, um, by instantiating the ADT, let's say with a value of one, and then mapping over that and adding a value to that, and then chaining with that. And again, we've got to return a new ADT, or ID. So we'll just say value plus 2, right? And that returns a new one. And then we'll do an extract. And then let's just log that out. It's great. So that's a very simple ADT. But let's look at um, side effects like, promises or fetches or any kind of call that actually does something to the outside world. Console log is an example of a side effect. But basically, what we would like to do is be able to, kind of wrap a function around those side effect functions, and then we can just pass that function around in our pure business logic area, And then when we get ready to um, run at the very end, we can call a function called fork that will essentially execute all of those wrap functions and actually execute the side effects at the edge versus inside our business logic. So let's see if we can take our um, friend the array and kind of make it a ADT that will wrap, kind of side effect functions around and not call them until the end. So let's see how that looks. So a common procedure for this kind of wrapper function is a function signature that takes a rejected function and a resolved function as arguments, and then it will either call rejected or resolved based on some value. So for starters, let's just say resolved hello, right? And that's our kind of function that we want to add to the array or the container as a value. So we can just start with the container and we can just put the function in the container. And then we want to kind of get the function out and then run the function, right? Run each of the rejected and the resolved functions, or call the function passing it and a rejected and a resolved function. This can be called fork. So we can create a function called fork, and what that's going to do is it's going to take a function and then it's going to run that function, passing in a rejected function where let's just console log, we'll just do rej colon, and then the value, and a resolved function, right? And we'll just console log res colon and the value. Okay, so that's our fork. And what we can do is just keep this simple. We can take our function that we put in a container and then we can pop it out and then run fork on it. And let's see, we got an error. Okay, what am I doing wrong? Resolved, hello. No comma here. There we go. So we got a solution and it returned hello. Now, this is very contrived and basically we're just saying x equals function here, but let's add a map, right? So what if we wanted to map over a function? What would that look like? Well, when map is called, it's going to give us the value, and that value is a function, right? And what we're going to want to do is we're going to want to return another function that meets that signature, right? So we're going to want to return a function that takes a rejected and a resolved. And then inside that is where we can actually do some work. So we can call resolved right? Because we want this to be um, a successful result. We could call rejected if we wanted it to reject or become a rejected kind of state. But we're going to call resolved. And when we call resolved, we need to give it a result. And we're going to use the function that is the value passed in, and we're going to call it. And for rejected, we're just going to create an identity function. And for resolved, we're going to pass in a function that takes the value and then increments the value or concatenates it with the string space world, right? And then we'll close that up, which I think we have here. Just have to add one more there. So now we're going to take this function as a value, put it in a container, then map over it and return a new function, which will replace that value, just like we did a 1 and a 1 plus 1, 2 replaces that. It's going to replace that function with this function, which is going to resolve it. So at the end of the day, we should log out hello world if everything works right. Let's see. Do I save it? Yeah, it did, and it's still okay. So I need to fork X. There we go. Um, so that's kind of the concept. That's the concept of an async ADT is that we take this function signature and we wrap functions in it, and then we can map and chain off of that, all really working at the function level. But we want to kind of remove some of this boilerplate, right? Because it would just be super painful having to do that all the time, and it's pretty easy to remove. So let's do that. Let's remove some of that boilerplate and create a async ADT. So we've got sync, and we're going to take that function and we're just going to call it fork because we actually call the fork function. And that is the signature. It takes a rejected and a resolved, and then it either is going to call the rejected or call the resolved when it runs. And that gives us this way to wrap kind of side effects. Let's return an object, and on that object we're going to have the fork function, and we're going to have a map, and we're going to have a chain. Okay, and that's all we're going to have for this simple type. And we can add more functionality to these, and we'll show that in a little bit, but let's just stick with map and chain for now. Okay, so when we did map with the ID function, we really just uh, basically took the function and then we took the type, in this case async, and then we ran the function with the value, right? Something like that. But since we have kind of two potential pathways, we have to do a little bit more. So in this case, we still want to return an async because we want to take the value and replace it into the container um, once it's passed to us. So we're going to create a rejected, resolved, or fork kind of function. And then we're going to call fork, right? We're going to call the value and pass in the rejected function that's passed into us. And then for the resolved, we're going to pass in this function that will give us the value, and then we're going to call resolved on that value, right? Or actually, the result of function and resolved value. Okay, so that is kind of super complicated, but basically what we're doing is if it's rejected, we just continue down the chain. So that'll kind of escape out. If it's resolved, we actually want to invoke the functionality by calling the function that's being passed in with the value that's kind of wrapped inside the other function, and then resolve it. And that allows us to, when we're actually coding, to code as if we're working with values that have not been called yet. And that's pretty crazy, but it works. So I'm going to comment out chain because I think that I will confuse myself trying to explain chain right now. But I do want to create a helper function, a sync.of, which will take a value, and basically what we're going to do is return an async. And this is kind of going to just inject this value or wrap it in a function, right? In a sync function. So I'm going to do rejected, resolved, and then we're going to say resolved v. And this kind of works like a constructor so that we can just sort of start with a value, and then we can map over it and then fork it. And you'll kind of see what happens there. So if we do a sync.of with the value, and then we map the value, and we can just now, just like we did with the identity function, we can just do value plus 2, and then the difference is we're not going to actually run it. It's just going to wrap it into another function until we run fork. And then when we run fork, we can take our error branch, if you will, our rejected branch, and we can log that out. And then we can take our resolved branch and log that out. And if everything works correctly, we should get resolved something. And we don't. Okay, so I need to give it an actual value on a V. There we go. Resolved 3. Awesome. And that is kind of the async ADT. Let's see if we can do the chain method now. So the chain method replaces the value. So in this chain method, we're going to take a function and we're going to return an async, right? And then an async has a rejected and resolved function, right? Signature, rejected, resolved, function signature. And then we're going to call fork. And with rejected, we just pass go, collect $200. And with resolved, we take the value, we call it on the function, which should return us another async, right? When we call that function, it'll return us an async container. So then we're going to call fork on it, and then we're going to pass rejected and resolved. And that gives us a chain or a flat map in this async component, which is pretty cool. So if I do a chain and take the value, which will now be 3, and then return a new async, and let's say 42, just like the identifier, the ID ADT, it should just replace the value with 42. And it does. Sweet. So now we've got this ADT that follows the same kind of pattern that the ID ADT does, but we're actually wrapping functions. So those functions can actually wrap side effects. Let's look at an example. So a common example is a promise. A promise is a function that will most likely result in side effects. We can actually wrap that by using a helper method. Let's call it from promise. And this helper method will basically take a function that is a promise. Let's just call it promise. Maybe that'll be easier to understand. And then it's going to create an async wrapper, just like the of took a value and created an async wrapper. So this one's going to take a promise, and we got our rejected and our resolved. And then we call the function, right? And we do a dot then, and pass in resolved, and then a dot catch, and pass in rejected. And this kind of wraps any promise with no arguments. We'll deal with arguments another day, but with no arguments into an async ADT. Now we can take this from promise, right? And it's going to take a function. We'll just say promise dot resolve 1, right? And now from promise is an async, but now our value is this promise, which could be a side effect. It could be a fetch. It could be any other kind of async function that would go out and do something. So it doesn't get called until we call fork, but we can treat it as if it did get called. So we could treat it as if it did, which would return a value of 1, and then we can add 2 to it, and then we can replace it as well. So let's see if this works. Uh, cool, it did, because it didn't change. Let's just prove that it works. Yeah. So just like that, we have a way to wrap side effects into pure functions, pass them around, manipulate their values, but not actually really call them until we call the fork function. I know that that is a lot to think about and a lot to get your head around. The big reason why we want to do this is so that we can separate our side effects or actions from our pure business logic. So we can do map chain on all of our business logic using very simple pure functions. And then when we're ready to execute those side effects, we just call fork. And it just keeps everything nice and clean and easy to reason about. So hopefully that helps. I'm going to post some notes in the description, and hopefully, you start using these async ADTs. I'll guarantee you, if you take the time to learn this and wrap promises and other side effects in this, you will have much cleaner code, easier to debug, and you'll be happy because you won't be fighting these kind of problems that can kind of come out of nowhere. So thank you for your time. I hope you have a great day.